Let us see. Question number 10 here. What does question number 10 say? Question 10 says, in the diagram below, you have a cubic function, and then you have a straight line graph. They said F and G intersect at A. And then it looks like we have another line. This other line here, we don't know what it is. It's H. They didn't say anything about H, but they said H is a tangent at A. And then it says, then calculate the coordinate of B, the x-intercept of H for 9 marks. So you see, this is what I was saying. If you are a CAPS learner, the only difference with IEB questions sometimes is they just need you to do a lot of things for one question. They don't like hint you and ask you small questions first and then a big one. They just ask the big one and they just make all the marks together. That's the only difference with your CAPS and your IEB papers. So let's just carry on from there. Carrying on from here, yeah, let's read again. They said h of x is the tangent at A. Calculate the coordinates of B, the x-intercept of H. So it looks like if you can get the equation of H, getting the value of B is going to be very, very easy. So let's just get the equation of the tangent to the curve. That's literally all they're asking us here. They're asking us to get the equation of the tangent to a curve. Once we get the equation of the tangent to this curve, we can just get what they're asking for. That's why you see I'm saying IEB, it's not harder. They're just asking one big question without asking smaller ones first. So anytime you need an equation of a tangent to a curve, there's one thing that the curve and the tangent share. As I've said already, they share a coordinate, right, which is a x and a y value. What they also share is a gradient at a specific x value. So for a specific x value, they also share the gradient. And this will be the same x value that you throw over here, the same x value that you throw over there. Those are the two things that the tangent and the curve share. So what you know is the tangent and the curve meet here. We can get this point here by making f and g equal to each other. So let's do that first. But before making f and g equal to each other, no, actually let's do it, because it doesn't seem like it's a difficult thing to do. It actually looks like it's a straightforward thing to do. So let's do it. So here, f of x equal to g of x, we're going to have here x cubed minus 5x squared, right? And then you have minus 5x squared, and then you have like plus 3x, and then plus 9 equal to 3x plus 9. So the 9 and the 9 will go to the same side, they'll cancel each other. You have x to the power of 3 here minus 5x squared plus 3x. The 3x and the 3x will also cancel each other because this is a plus 3x. You're going to take it over minus 3x. This is going to give you a 0. Now you can factorize x squared, x here minus 5 equal to 0. You have x squared equal to 0 or x minus 5 equal to 0. It means that your x is a 5 or your x is a 0, which makes sense, you see, because you have 2 points where these graphs meet each other. The first point here is where x is a 0 clearly. The other point here was clearly seeing that the x value is a 5. The y value we don't know, but we're about to find it. Getting the y value there, which is obviously necessary, because we're trying to get as much information as we can from this sketch to eventually get the equation of h. Getting the y value, we can throw it into this equation of g here. Y value is a 5. Put a 5 there. 5 times 3 is a 15. That's like 15 plus 9. And then you have like 24 as the answer. So now you have a coordinate that the graph and the tangent pass through. What's important is actually the value 5, because the value 5 is the same 5 that will get you the gradient at the point where they meet. Because if you get the gradient here at the point where they meet, it is also the gradient of the tangent. The reason we need that is because if you want the equation of our tangent, right, the standard form of any straight line is mx plus c. So we need a gradient and a y-intercept. apart from needing a gradient at a y-intercept. Fortunately, we can use this format. Y is equal to, no, x minus x1 is equal to m x minus x1. So we have to get a gradient and we need a coordinate that the graph passes through. So a coordinate we have, right? It's only the gradient that we still need to find, of which the gradient we can find it easily from what we're about to do. We just want the gradient at this point. So getting the gradient at this point, we can use our first derivative of our cubic function, because remember, our cubic function, if you want to find out any gradient at any point, what you do is you take your first derivative and you make it equal to a 0. So let's take our equation of f of x, right? This is what f of x looks like. We want to differentiate it and make it equal to 0 and so for x, so that we can find the x value where you have a gradient of a specific number. So we want to find the gradient where the x value is a 5. That's going to be the gradient of our tangent. So to do that, let's just create ourselves some space here because we have just been too reckless. Let's move this over here. Move this over here. Move this over here. So differentiating once here to get our gradient equation, you're going to have here 3x squared minus what? Minus 10x plus 3. If you make it equal to 0, you know that you want a gradient where the x value is a 5. So where x is, you put a 5 because that's the x value for which you're looking for a gradient. No. X gradient is not equal to a 0. You're looking for the gradient where the x value is a 5. So gradient is left open. And then you have x value a 5 because you're looking for a specific gradient. You don't want to get where the gradient is a 0. The gradient is a 0 here. And the gradient is a 0 here also. But those are not that's not what you're looking for. You're looking for the gradient here. So you don't know what the gradient is. So you leave this one open, but you know it's at an x value of 5. So all this 5 squared is 25 times 3 is 75 minus 50 plus 3. The gradient at 5, let's see, 75 minus 50 is 25 plus 3 is 28. There you go. So does that make sense? Yep, we have our gradient there. So once you have your gradient at that point, you automatically have the gradient of the tangent that you are working with, you see. So once you have the gradient of the tangent that you're working with, you're home free, because now you can find out this information, you see. So y minus y1, the y value is 24, remember, gradient we have found it as 28, x value we got it as 5. So this is going to give you the equation of your tangent. So getting the equation of your tangent, 28x minus, it's a big number, eh? Let's just break it. Break it what? I need a calculator. Calculator, help me, please. Because I don't want to do mental math. Let's see, 28 times 5, right? 28 times the 5 there, it's going to give you 140. Negative 140. Then this is y minus 24. The 24 goes over, you would add it, right? So you adding it, you'd have 28x. Negative this plus this, right, gives you a negative 116. There you go. So this here, you want to get the x-intercept. So you make y a 0. So y becomes a 0 here. 28x minus 116. This is like positive 116. And then this is 28x. So you're going to divide both sides by 28, 28, 28. Our x value is equal to 29 over 7. So yeah, that is quite a distinct answer, but you can see that our question is definitely does not pulling any punches, but it looks like an equation. You can see that that's what I'm trying to say with IEB. IEB, they just ask one big question all at once instead of like leading you on by asking things like, they could have easily maybe, caps would have maybe said, get a coordinate of A as one question. Then caps would have said, get the equation of the tangent only, and then they'll make that a 4 and a 5 mark question. But here IEP, they just put it all together. That's the difference, you see. You can see none is harder than the other. But anyways, you have X, they want the coordinate, right? So you have to say, therefore, X value, and then Y value. That's the coordinate of B, as they are asking. So it is all good. Let's move on. They said here B, it says the following information is given, right? You have this is a first derivative. So this is a gradient equation. Now it says here, in the original equation, right? The Y value is 0. This equation here, if your Y is equal to 0, this has a negative real solution. So whatever this is going to sketch a parabola, which is the first derivative. It means the original equation is actually a cubic function, you see. Ax cubed plus bx plus cx plus d. This is a parabola. It's a smiling parabola, you see. So these y values would be representing the gradients of this graph. Now they told us that this cubic function, right, whatever it is, it's a positive cubic function. It has one negative real solution. So what that means is, if your first derivative is smiling, it means that your original graph also goes up, down, and then up again. So if it has one negative solution, it means that this is saying if you solve for x, right, and you make y as 0, your graph is only going to touch the x-intercept once, and it's going to touch it on the negative side of your Cartesian plane. So you're going to have maybe something like this, where your graph does not touch your x-axis again. It only touches it once on the negative side. So this is a rough sketch of your image. All this is based on the theory that you need to know about all this work. Now, if you sort of like looking at what we're doing now and you're asking, bro, how did you just do all that? You can easily look at, for example, something that's on the main website, on the main YouTube channel rather. On the main YouTube channel, there is an application of calculus, what you call playlist. In that application of calculus playlist, right? The one thing that is definitely clear there is there's a tutorial here. It says graph of the derivative of a function. You can see here, this tutorial, it basically touches on how the parabola, or how it touches on how if you have a cubic function, right? You can differentiate it and you'll have a parabola, and then differentiate it again, you'll have a straight line. And it basically talks about how all these are linked together. So you can watch that. But obviously, if these kinds of questions are also a bit difficult, right, then it means you need to sign up for the online courses. The online courses on the website, as of this recording, you have a huge sale of 99 Rand only. So obviously you can just hop on there. If you're in grade 11, this is going to help you also, especially if you're doing IEB, because the idea is 70 to 80% of all this work is grade 11 work anyways. This gives you access to all the online courses on our website. You can see here, it's an application of calculus course, and it's on sale from the 23rd of October until the 7th of November, depending on when you're watching this. But anyways, this is what our rough sketch looks like without a doubt. For 4 marks, it said, for what values of x is f of x increasing. So your graph is always increasing where your y values are going up. So the two things that you have to look for is the two turning points. So what I mean by that is, if you're walking on this graph, as long as you're walking like upwards, the graph there is increasing. You see, you're walking upwards, so the graph is increasing. Here also you'll be walking upwards, so the graph is also increasing. So it's increasing from your one x value of your turning point to the other x value of your turning point. So we may not know where the y intercept is, but let's just leave that out for now. So this is where your first derivative is going to come to bail you out, because clearly we need the turning points. Fortunately, to get the x values of the turning points, we need the first derivative, and you need to make it equal to a 0. So let's make our first derivative equal to a 0. The reason why we're making our first derivative equal to a 0 is because we need the x values of our turning points. If we get the x values of our turning points, we can say the graph is increasing from this x value going to the left and from this x value going to the right. So let's solve for x. The 4 can go over. At this point in time, you have to be careful to definitely put the plus and the minus when you put stuff in under a square root. Otherwise, you will not get two answers. And that's going to be a problem, you see. So here, your two answers, you have to start one where you use a positive 2, the other one where you use a negative 2. So that being said, the one goes over, you have x as a 1. The one goes over, you have x as minus 3. Hence why you see I left out the y axis because it was going to ruin things. But let's see, this x value is a negative 3, this x value is a positive 1, you see. So answering your question is definitely going to be a bit easier because of that knowledge that you have, you see. So here you're going to say your x values are smaller than negative 3, or those same x values are bigger than 1. Nothing crazy, nothing major. You're going to get 4 marks. Your theory is important, you see. So you can see IB just has deeper questions, but the content and the knowledge is the same. Here, 2 says use the information above to sketch the graph of f on the same set of x's below. Label the x values of the turning points and the x and the x value of the point of inflection. So the x value of the point of inflection is just an x value that is in the middle of our 2x turning points. So I mean, like, we have already done this question in the previous one. So this is 5 marks. It's going to be easy 5 marks because we already drew the graph to help us work out what we were working out. So this graph, since our turning point is at, let's say, like negative 3, right? Obviously, we're going to maybe move our graph something like this because it should not touch the x-axis twice. So this is what our image looks like. You see, we already stated that one of our turning points is at negative 3 here. The other one is at positive 1. The point of inflection is going to be in the middle of your two x values of your turning points. So you're going to find the middle of negative 3 and 1. So you add those up, you divide by 2. It's going to give you negative 2 over 2, which is like negative 1. So there you go. See, this is a negative 1. So that's quite straightforward. They just want us to get that. They said we should label the x values of the turning points. We did. And then the x value of the point of inflection. We did. And then we should just draw the sketch. We did. You see, so you're going to get your 5 marks here without worrying about adding any unnecessary piece of information, you see. So as long as you show your negative 3 there, you show your other negative, your positive 1, and all those other stuff, you're good. Now, they didn't say anything about what you call, what did they say? They didn't say anything about anything else, you see. You have a graph here where you have a negative x-intercept, yes. And that negative x-intercept, it clearly does not need to be labeled because we don't have that value. And then the turning points that we have labeled them. We've labeled the x values, and we've labeled the x value of the point of inflection. That's all you need. Anything else that you may see on this sketch, wherever you will be seeing it, it's just extra information. And we really don't need that, you see. So let's move on.